Hi future doctors, welcome to the next class. In AC we have done pure resistor and inductor. We will see pure capacitor. AC source connected for pure capacitor. So if you are taking one capacitor of capacitance C, if it is connected to source of AC, E is equal to E naught sin omega t or V is equal to V naught sin omega t. Call it as equation number 1. Now capacitor and source both are going to be connected in parallel. Now what is the voltage across capacitance? V is equal to, we came to know Q is equal to CV. So V is equal to Q by C. That V only. So V naught sin omega t. So from this Q is equal to V naught C sin omega t. Now we want current. If you differentiate this, psi is equal to dq by dt. So d by dt of V naught C sin omega. So if you write V naught C outside, derivative of sin omega t. Derivative of sin omega t is cos omega t into omega. In basics we give. Okay, this one can be represented. I is equal to V naught omega C cos omega t. So this omega C can be written as 1 by omega C cos omega. So I is equal to, so I naught cos omega t, I is equal to I naught. This cos omega t can be represented as sin omega t plus pi by 2. This is the alternating current passing through the capacitor. So where I naught is equal to, so V naught by 1 by omega C. So always voltage denominator will be represented as resistance. Here capacitance or capacitor is going to oppose alternating current. So the opposition offered by capacitor to the flow of AC we will call capacitive reactance. Capacitive reactance. So reactance is also resistance, but why we are calling differently means because this is offering resistance for alternating current. So friction, viscosity both are going to be same. So friction will be saying for objects, viscosity will be saying for fluids. Same like that. Reactance for alternating current, resistance for direct current we are going to say. Now Xc is going to be, if it is inductor, XL. If it is capacitor, X. Xc is going to be 1 by omega C. That is going to be 1 by 2 pi Fc. So what is the relation between Xc and F means? That is inversely proportional. So what is the nature of the graph? It is inversely proportional means in basics we discussed rectangular hyperbola. This one also we discussed in basics. This is mathematics completely, but for physics it will be coming under basics. Next, according to this equation here, plus C is going to be there in between. Therefore, current leads voltage by pi by 2. In case of inductor, current lags. In case of inductor, current lags voltage. In case of capacitor, current leads voltage by pi by 2. Correct? Now, if you have shown phasor diagram and wave representation. So first we will see wave representation. So this is going to be, always we are drawing so many times, V is equal to V naught sin omega t. So this is going to be V naught. This is phase means wave representation of applied source of voltage. Now for this, I is equal to I naught sin omega t plus pi by 2. So current leads. Current leads. Therefore, it will be coming like this. So this is going to be I is equal to I naught sin omega t plus pi by 2. Next, phasor diagram. So for phasor diagram, For inductor case, if you have shown voltage like this, so current we have shown here because current lags. Now current leads by how much angle? Pi by 2. Therefore, this is going to be I naught and this is going to be V naught. Next, this is going to be omega t plus pi by 2. So, omega t plus 90 degrees, that is the phasor diagram. So, in this new terms you got capacitive reactance, inductive reactance, and depending on wave representation and phasor diagram representation, so which one is going to be, which component is going to be available in circuit? Pure capacitor, inductor and resistor. For resistor, both will be starting from same position. So for inductor, EMF is starting from here means current will be starting from here. So in capacitor, so first current leads, therefore current will be starting from first. That representation difference you should remember carefully. Now we will see a small comparison. In case of resistor, pure resistor, both current and voltage in same phase. Same phase. So if V is equal to V naught sin omega t. So in case of resistor, I is equal to I naught sin omega t. So where I naught is V naught by R. So in case of inductor, so I and V not in same phase. Phase difference between current and voltage is pi by 2. So that I is going to be represented as I naught sin omega t minus pi by 2. So I lags voltage by pi by 2. Any one you can remember. So current lags voltage by pi by 2. Now what is I naught here means? Where I naught is V naught by XL. XL is going to be omega L, that is going to be 2 pi FL. So XL is we are calling it as inductive reactance. Next, in case of capacitor, just now we discussed. So I and V again not in same phase, they are out of phase difference, that is also pi by 2, but I is equal to I naught sin omega t plus pi by 2. So where I naught is V naught by Xc and Xc is 1 by omega c, 1 by 2 pi Fc. Here current leads voltage by pi by 2. So this phase difference should be very important. Here phase difference phi is going to be 0 in case of pure resistor. Now this one generally we will call resistance offered by any component to the flow of AC, we will call reactance. Reactance is nothing but resistance. Now what is the reciprocal of resistance we came to know? Reciprocal of resistance is nothing but conductance. Tense will be coming. Already we discussed in current density. Reciprocal of resistivity we will call conductivity. Same like that, what is the reciprocal of reactance? And reactance units also ohms. Resistance units, reactance units, both are going to be same. Now reciprocal of reactance is nothing but susceptance. Susceptance is nothing but reciprocal of reactance. So how conductance units will be coming? Same like that, susceptance units also will be coming. So this is the small comparison about pure resistor, pure inductor, pure capacitor. Okay.